Well, welcome to our lesson on quadratic functions. Today we're going to make the leap from talking about all linear equations to quadratic functions. And a couple of quick learning targets for you. By the end of this lesson, you should be able to graph a quadratic function by using a table of values. You will be able to find maximum or minimum values of a quadratic function. You'll also be able to find the vertex, the y-intercept, and the equation of the axis of symmetry. So in order to learn all of those things, I need to define what they are and give you some direction here. So a couple of very fundamental things about quadratic equations or quadratic functions. They are functions, and we have talked about this in class. A function is something that will pass the vertical line test, and they are also second degree polynomials. They're not linear, they're curves. So their degree is 2. That's the highest exponent that you're going to have. And then they all graph as what we call a parabola. They are U-shaped. They may curve up or they may curve down, but they are all called parabolas as far as the shape when you graph them. So in standard form, the equation of a quadratic equation looks like this: ax squared plus bx plus c. There are usually 3 terms. It may not have a linear term or it may not have a constant term. As long as it has the quadratic term, then it's a quadratic equation. So each of these, make sure you understand when I refer to the quadratic term or the linear term or the constant term, I have defined those for you here. Now a, b, and c are just numbers, and then your variable is x. Okay, and you will see it represented as f of x. Remember, that means the same thing as y equal to. This is just function notation. So f of x is the same as y. Now, a couple of other things on the graph of all quadratic equations. You will always have this line of symmetry right here, that red dotted line that you see. That is called the axis of symmetry. And basically, if you were to fold your parabola along that line, it would be symmetrical about that line. Both sides would be exactly the same. We talked a little bit about these points where it crosses the x-axis. Those are called zeros. And in our next lesson, we'll talk a little bit more about those. We're not going to talk a lot about that in this lesson, but just remember where it crosses the x-axis, those are called zeros. Where it crosses the y-axis, we keep that as the y-intercept. That does not have any new unique name. It's the y-intercept, just like you're used to with linear equations. And then this point right here at the bottom, at the apex of your parabola, that is called the vertex. Now that vertex could be at the bottom, or if it opens the other way where it opens down, that's still called the vertex. Okay, and that vertex is going to be a maximum or a minimum point. So let's go ahead and talk a little bit more about each of these vocabulary terms. So the y-intercept, where this graph crosses the y-axis, that's the point when x is always equal to 0, and it's where it crosses the y-axis. Okay, so if we go back to our standard form, I have it listed for you down here. If you let both of these terms with an x in it be 0, then you just have f of x equals c. So the y-intercept is just the constant term. Okay, so y equals c. So you can just look at the equation and know where it crosses the y-axis. You can find that y-intercept just by looking at your quadratic equation. The vertex down here in this example is the point where that axis of symmetry intersects the parabola. By definition, that's where the vertex is. It is at that point. The x-coordinate of that point is equal to negative b over 2a. So negative b is the coefficient in front of the linear term, and then double the coefficient in front of your quadratic term. That's how you find the x-coordinate. So that's a formula that you will need to remember, okay, for finding the x-coordinate. Now the zeros are the points where the parabola crosses the x-axis. So that's where y would be equal to 0. So we would let f of x be 0, and then we would solve it for x. We'll get into that in future lessons. We're not going to talk about that a whole lot today, but in future lessons we will. The axis of symmetry, you already know how to find the x-coordinate of the axis of symmetry because that's the x-coordinate of the vertex. Okay, and that's that same formula, x equals negative b over 2a. But the axis of symmetry, remember, that's a vertical line, and all vertical lines, you already know, have the form x equal to a number. So this axis of symmetry is always going to be x equal to, and it's just a number. Remember not to just write what the number is. It is an equation of a line. So it's x equal to the number. And then we have a maximum, and the maximum value is the coordinate of the vertex, excuse me, when a is equal, or excuse me, when a is less than 0. So what I'm saying there, if you look down at these two pictures, when the parabola opens down, you get a maximum point, and that happens when this a coefficient is negative. A less than 0 means it's negative. So if you have a negative x squared term, you already know that graphically this thing opens down and it has a maximum point. If a is positive, then you get a minimum point and it opens upward. Okay, so when a is a positive number, so the coefficient in front of your quadratic term tells you right away just by looking at the equation whether it opens up or down and whether it has a maximum or a minimum point. The domain is all real numbers. Remember, the domain is what x can equal. So if you think about this, x can equal anything. Okay, as we go further out on the x-axis, we'll just be up higher on the curve. X can be negatives, x can be positives, it can be anything. So the domain on all quadratic functions is all real numbers. Now you may have to set some limitations based on the specific problem, but in general, the domain for quadratic equations is all real numbers. Remember, the range is what the y values can equal. Okay, what are the y values? You can see the range on this one, you're going to have a minimum y value. It's not going to get any lower than that, so you will have limitations here, and then it'll go forever in the positive direction. When a is negative, you'll have a maximum value for y, but then it will go to negative infinity. So the range is all numbers greater than the minimum, so anything bigger than the minimum, and anything less than the maximum. So that was a lot of information in one slide. So let's go ahead and look at some examples of how we can figure some of this stuff out. So here we have, it says, graph this function, this quadratic function, by making a table of values. Well, this is just creating an XY chart, and we're going to plug in some integer values of x and see what we get out of the function. So first of all, if I plug in a 0 right here for both of the x terms, okay, I end up getting 9. So that's the point 0, 9. Okay, and we'll end up graphing that. What if I plug in a 1? Well, 1 squared is 1. Multiply by 2, you get 2. 2 minus 8 is a negative 6 plus 9, which gives us 3. So that's the point 1, 3. What if we plug in a 2 for x? Well, then we get out a value of 1. Okay, so this one is 2 squared is 4 times 2 is 8, and 8 minus 16 is a negative 8 plus 9 is 1. So that's the point 2, 1. Plugging in the value of 3, we get out a 3, so that's the point 3, 3. And then a 4, we end up with a 9, so 4, 9. So now what we want to do is just plot these points. So you have to be really careful doing your math, doing the substitution of those values to make sure you get the right numbers. And if you plot those points, here's what you end up with. So we have 0, 9. When x is 0, y is 9. That's our y-intercept. We found our vertex in there. That happened to occur at 2, 1. And then you should always get two values, just depending on what you choose for your inputs. You should always get this curve like this. Okay, so that's graphing just by making a table of values. And that will always be an option for you. So here we have another function. Okay, in this case, a is negative 1, b would be 2, and c is negative 6. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So first of all, let's talk about the y-intercept. Remember, the y-intercept is where it crosses the y-axis, so we know x is equal to 0. If I let x be 0 in this equation, I should get out negative 6, and I do. Okay, so the y-intercept is negative 6, so it's going to be down here somewhere. The axis of symmetry, that's given by that equation. It's x equal to a number, and the number it's equal to is negative b over 2a. So I take the opposite of 2, so I have negative 2 over 2 times negative 1. So I have negative 2 over negative 2, which is 1. So x equals 1 is the equation of my axis of symmetry. X equals 1, excuse me. So at x equals 1, you'll have a vertical line. Okay, we usually make that a dotted line, and I'll show you the graph in a minute. And then we need to find the vertex. Well, we already know the x-coordinate of the vertex, but to get the y-coordinate, what we need to do is plug in x equals 1 into our equation. We need to evaluate the function at that x-coordinate, and then we can get the y-coordinate. So the vertex is the point 1, negative 5. Okay, we get negative 1 plus 2, which is a positive 1, minus 6, which is negative 5. So now we can make a table of values. That's always an option for us. I plugged in 0, okay, and I got negative 6. I plug in 1, and I end up with negative 5. If I plug in 2, I get a value of negative 6. If I plug in 3, I get out a negative 9. So those are 4 different points that I can go ahead and plot. And we know a lot about it just by doing these 3 things up here. So I went ahead and graphed those points, and those are indicated. I don't have the exact points here, but 1, negative 5 was our vertex right here. 0, negative 6 is right here. And then we have the point 2, negative 5, or excuse me, negative 6 is here. And then 3, negative 9 goes further down. Okay, so 3, negative 9 is also on our graph. So that's the point right here. We would also get, if we calculate negative 1, we'll get negative 9 as well. So you can see that you have that axis of symmetry at x equals 1. So our last question on this slide says find the maximum or minimum value and state the domain and the range. Well, it looks like because it opens down, we have a maximum value, and that maximum value, what is the y-coordinate at that vertex? Well, we already calculated that. That value at the vertex, the y-coordinate is negative 5. Okay, so we already know that it has a maximum, and that value is negative 5. It's never going to get any bigger than that. It only gets smaller. The domain is all reals. Okay, that's true for all of our quadratic functions, and we don't have any limitations on this one. How about our range? What kind of values will we get on the y-axis? Will we ever get anything up here that's a positive value on the y-axis? The answer is no. We already said our maximum is negative 5. So all of our range values, anything we get out of the function, will be smaller than negative 5. So the range is y is less than or equal to negative 5. So here's another example. It says, suppose an object is fired straight up from the top of a 200-foot building at a velocity of 80 feet per second. The height, h of t, of the object, t seconds after it's fired, is given by this quadratic equation. So we have the height, t is time, and you can see that this is a quadratic equation because it has a t squared term. This is my quadratic term, this is my linear term, this is my constant. So I kind of drew a little diagram here. Imagine that this is a building right here. Here's my y and my x-axis. We're going to shoot this thing up in the air, and it's going to come down. So that's kind of a parabolic trajectory is what we would say. It says find the maximum height the object reaches, and when it reaches that height, we want to know what is the y value at that top point right there. Okay? What is the output or the y value? And we also want to know what is the x value? What time does that occur? And what value does it have? So we want the coordinates of the vertex. That's what that's asking. So the maximum height occurs at the vertex. And remember, the vertex is that the x-coordinate is negative b over 2a. And so we're going to find negative b over 2a. So in this example, if I grab my marker here, let me pick something that you can see. So in this example, a is negative 16. B is equal to 80, and C equals 200. So those are the first things you need to be able to recognize. So the coordinates at that vertex are negative B, which is negative 80, over 2 times negative 16. Okay, so I have that worked out for you. If you punch that into your calculator, you get 2.5 seconds. That's an x value. So x equals 2.5 is the equation of our axis of symmetry, which happens to be the x-coordinate of the vertex. If we plug in 2.5 into our function for t, in this case, right, it's h of t, so anywhere we have a t, we're going to put in 2.5. So we would have negative 16 times 2.5 squared plus 80 times 2.5 plus 200. Plug that into your calculator, you should get out 300 feet. So that tells me up at this top point right here, okay, we have a point right there. And if we go across, this point right here will be 300 feet. And that happens at 2.5 seconds, okay? So x equals 2.5 and y equals 300. So what are the domain and range of the function? Well, we said the domain is all reals, so we're going to leave that as all reals. What is the range? Remember, I have a maximum point. We're never going to get above that. So the range is going to be anything below or equal to 300. It does hit 300, so all values below 300. The second part of that question says, what domain and range values make sense in this situation? Now, one of the things, do we care what happens? We need to interpret this a little bit. My x-axis is actually representing the ground level. This thing will continue to go down. If we didn't have a ground level, let's say we were on a cliff or something, this would continue to go down. Or what if we were in a bottomless pit? This would continue to go down, 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 down. But we actually are going to say that the x-axis is the ground, so we're not going to let x go negative. Okay, we're not going to, or excuse me, we're not going to let y go negative. The x value, we're not going to go beyond the point where it hits the ground. So we need to figure out what is that value. And we talked about that being a 0. And for right now, the only way we're going to find that is to use our calculator. And so what I did was I went ahead and put this equation into my calculator under y1 equals, so instead of h of t, we're calling that y. And then we would say negative 16x squared plus 80x plus 200. Put that in your calculator, and you're going to have to be smart about this, because if you let t be 0, at time t equals 0, we're already up at 200. So you're going to have to adjust your viewing window. And so you know you need to have from 0 to at least 300 for your y values. Okay, so that would be a good window for you. For y minimum, maybe 0, y maximum, go a little bit above 300, so you'll see that top part. I might go to 325, just so you see that. And then let your x values go from maybe 0 to 10, and you should get a good picture of that thing. Okay, and so when you do that, we're going to limit our domain. You'll find that this 0 right here, if you calculate the 0 value on your calculator, do the second calculate 0, and do your left bound and right bound thing, you get about 6.83 seconds. So our domain, it doesn't make sense to have negative time. So even though we say the domain is all reals, this is a situation where it only makes sense to go from 0 to 6.83 seconds. And then our range, we're not going to have any negative values below the ground, so from 0 to 300. So those are the ones that make sense in this situation for this problem. Interpret the meaning of the y-intercept. Well, what is the y-intercept? The y-intercept was 200. If we let t be 0, we're at 200. What does that mean? Well, if you read your problem, it says, suppose the object is fired straight up from the top of a 200-foot building. That's just telling you that's your starting point, right? You're already 200 feet above the ground. So what that means is at 0 to 100, at time t equals 0, the object is 200 feet above the ground. So I have given you one problem here that I would like you to analyze. Here's a quadratic equation, and I want you to try all of these things. Go ahead and look back at your notes. I want you to try each of these things. Find your y-intercept, the equation of the axis of symmetry and the vertex. Keep this as an equation. It's x equal to, okay? Find your maximum or minimum. It will be one or the other. State the domain and the range, and then make a table of values that includes your vertex, and then go ahead and graph it over here. You're only going to graph in the first quadrant for this one. So go ahead and graph at least 5 points there that make sense. And I'll check those with you when you come to class tomorrow. See you next time.